Hi everyone! In the previous tutorial, I showed you how you can connect Strudel to TouchDesigner using OSC communication. So this tutorial is kind of a part 2. I had some requests about this network and making it work with an audio file in. So in this tutorial, I will explain how you can use a song or any audio, analyze it and then put it into this visual. I will reuse the same network, so if you want to build it, you need to watch my previous tutorial. I will link it in the description. But if you don't want to follow along, you can find this project file on my Patreon. So I deleted all the chops that I showed you in the intro. The only thing that I kept is an audio file in with a song that I chose and an audio device out. I will disable the audio device out for now, so the song is not annoying for me, but I will re-enable it when we will connect it to the visual network. Now the first thing we want to do is we want to have a single channel here. To merge the channel or combine the channel, we will use a matte chop. And in combined channel, we will use average. After that, there's two ways you could analyze the audio. You could use the audio analysis in the palette. You just connect chop here, and then you can activate the low, the mid, the high, the kick, the snare, and the rhythm. What it will do is it will filter the low frequency, the mid frequency, the high frequency, etc. But for the sake of this tutorial, I want to show you how you can filter your own frequency with using the audio filter chop. So I will deactivate the low, the mid, and the high, but we will still use the kick, the snare, and the rhythm. We will grab an audio filter. In the audio filter, you have different variables, which you have the filters, low, high, bandwidth track, the cutoff unit. We will always use the frequency, and then you have the filter cutoff, the filter resonance, and then the roll-off that we will change in order to filter the frequency that we want. To help you understand how you have to split the frequency, I made this audio band split graph. This is just conceptual. It's not actually what it's supposed to look like with the audio spectrum, but it's just to give you an easy way to split them. So for example, the low, you will have all the variables that you have to change, and then just an example with what you could use it. Let's do it in TouchDesigner. For the low pass, we will use a filter low pass. Then the frequency cutoff would be 100, filter resonance would be 0, and the roll-off 24. In the common, we will rename it to low. We will copy and paste 3 times. On the second one, we will select the low to mid frequency. We will use bandpass. Frequency would be between 200 and 250, so let's say 30. Resonance 1.2 and roll-off 12. We will rename it to low mid. For the third one would be the mid. We will use a band pass. Cutoff would be 1000. Resonance 1. Roll-off 12. And again, we rename it to mid. For the high pass, the cutoff would be 3500. Resonance 8, and roll-off would be 18. We will also rename it to high. Next, what we want to do is to cut a bit of the spike and make it more stable. In order to do that, we will use an analyze chop, and then we will use the RMS power. So it kind of like remove all the noise or the spike around the filter, so it's a bit more easy to control afterward. We'll duplicate them for every signal. After that, it's optional, but you can use a lag just to smooth even more the signal. Next, we add a matte. Now we won't change the matte, but later we will use it to normalize our value between 0 and 1, so it's easier to use them in our visual network. Then we can just connect that to a null. I will just disable this so it won't affect our network. Okay, we will also use the kick, the snare and the rhythm, so I will grab a select chop, then select the kick, gate, and just the snare, and the rhythm. Can attach them to a null. Okay, we are now ready to connect it to the network. If we look at the network, you can see that in the transform, I changed the scale Z to the low frequency. We can now enable the song. Okay, so let's drag the low onto. In the previous tutorial, what I did with the scale is I wanted to keep the original value, so 1, and I wanted to toggle it between 1 and I believe 1.1 or 1.0.1. And now we can see that the low doesn't have those values. We could change the matte range, but we could also use the kick, the snare, or the rhythm in order to have a 1. I think I will use the kick. So I will grab a matte and connect the kick and the low together, and I will combine the chop using an add. Then I will connect a matte and I will change the range to 1.1 to 1. Okay, I feel it's a bit abrupt. I will add another lag. Maybe increase the value a little bit. Okay, let's keep this for now. For the noise, the C, I want to have an increasing count with the C. So what I did actually is I combined the kick and the rhythm, and then I use a count afterwards so it count upwards. Let's grab another matte, combine the kick and the rhythm, and combine chop we will use multiply. and then let's attach it to a null. We could use directly this value, but it would only toggle the seed between 0 and 1, so it will not create a sense of variety, if I can say like that. So we could add a count, and then it would always count upward, so the seed would be different every beat or every kick. Now we can change the amplitude. For the amplitude, I will go with the high. Let's see what does look like. Okay, now we can see that the amplitude is a bit high. In order to do that, we have to play with the math. So in order to normalize, we have to check what is the min and the max value. Sometimes it's difficult to guess because it's going very fast, but sometimes you can easily find it. We can see that it goes from 0 to 0.08 maybe. And then we want to decrease the value of the noise. Say maybe 0.1. Maybe it's too low. Say 0.3. It's a bit better. Could also increase the lag. Next, I want to have connection with the points. So we did use proximity in our last video, and we will change the maximum distance. For that, we can use the mid. We can also change the range for the math. This one would be more tricky, but let's say maybe 0.05 and then 0.03. Something else you could do is, instead of having a ramp here for the color, you could add some color to your design. So you could bring a noise and then change the period to maybe 7, change the type to simplex 4D, and disable the monochrome. In the transform, you could, for example, use the low mid on the translate, so it would change the color. We need to adjust the resolution. So in the map, let's copy the parameter and paste reference. So now we have the same resolution, and then we could, in the lookup, just drag the noise here. Reduce the exponent a little bit. Last, what we could do is change the bloom. For the bloom, I want to use the high value again, but I'm not sure this one is adapted. It would be too low. So what we can do is just duplicate and change the to range value for maybe 0.4, and then drag it again. increase it to 1. Yeah. Then we could also use a level with the snare to make it strobe. So every time there's a snare, like it will trigger 1, and then it would strobe. Could also use that. That marks the end for this tutorial. I hope you found this explanation useful, and then you can recreate it in your project. If you enjoyed this tutorial, please like, comment, and subscribe, and see you in the next one.